Hello and welcome to Assignment 6, Back of the Napkin. And today we are going to be talking about cavitation in hydraulic pumps. So for starters, let's just draw a simple hydraulic pump here. Have the propellers of the pump, and we have the exit. So on this side we're going to say this is our inlet, and on this side we're going to say it's our exit. Now it's important to keep in mind that for hydraulic pumps, they always operate with liquid. They're designed to operate to pump liquid from the inlet to the exit. And the liquid that we're going to be discussing today is water. And for this setup, usually there's a given inlet temperature, there's an inlet pressure, and also usually there's an inlet velocity of the fluid. And then similarly we have an exit temperature, we have our exit pressure, and we have some sort of exit velocity as well after the pump. So when designing these pumps, designers have to take into a very important situation, which is known as our not so friendly buddy over here. They have to take into account cavitation. Now what is cavitation? So cavitation, in order to understand it, we're going to draw a pressure temperature diagram here for water. So pressure's on the Y, temperature is on the X, and this is, remember, for water. So we have these lines here that separate the different states of water. So on this side we have solid, and then we have liquid, and underneath we have vapor here. So for this situation, we're going to say that the inlet temperature and the exit temperature is roughly the same, so we'll assume it's about 20 degrees Celsius. So there's no heat going into the system, there's no heat generated inside, so we'll just keep it easy. Say temperature is the same in inlet and exit, and then we're going to come down here, we're going to mark our 20 degrees Celsius, and then we come up. And now remember that these hydraulic pumps operate in the liquid region, so this is where the goal is. The goal is to stay in this region, and this is going to be our corresponding inlet pressure. Now cavitation is when the liquid that is flowing through this pump experiences a pressure loss. So remember, pressure would start to come down, and you move from this liquid region into the vapor region. Now designers, their main concern for this is right over here, right along this fin, the area right before the fin. So if we were to say this is state 1, so right over here is our state 1, our inlet conditions, and then as it approaches this area, the pressure begins to drop before it reaches the fin. So as the pressure drops, we move vertically down this line, keeping temperature constant, and we move to region 2, which is right over here. Now this pressure drop means that it doesn't mean that the liquid suddenly turns into a vapor. All of the liquid turns into a vapor, but you start to have, at this point, you start to have the formation of these vapor bubbles. So what that means is, along the fins, you start to have these vapor bubbles that are forming right before it. And keep in mind, these fins, this propeller, it's rotating at hundreds or thousands of revolutions per minute, and these vapor bubbles are impacting the fin at that speed. And over time, this causes extreme wear on the fin. So we're going to zoom in on one fin here. Over time, this causes the metal fin, it starts to deteriorate. There's metal flakes that begin to just fly off here. You start to have these areas where it's extremely rough, and a rough fin correlates to having an inefficient or an ineffective pump, because now the fluid doesn't, the liquid doesn't have a smooth surface to flow off of. So cavitation can affect the efficiency of your pump. It also, since you have these vapor bubbles impacting, it also causes loud noises as well. That it causes vibrations. And we know, so vibrations, it doesn't necessarily mean that the fin, but since the pump is all connected, the whole pump is vibrating, and this may cause another component to break down. So cavitation, it's important for designers to take into account. It's important for them to avoid this pressure drop from the liquid region into the vapor region so that the lifespan of the pump can be as long as possible, the efficiency of the pump remains relatively constant over time, and you don't have these loud noises generated as well as any type of vibrations. Thank you very much. Have an excellent night.